What's up, everyone? Welcome back. Patrick here. Moving on to the next question, still dealing with trigonometry. So you are standing on one corner of a large rectangular field. You walk diagonally and can reach the opposite corner in 10 minutes. The shortest side of the field is 800 meters. You walk at a pace of 9 kilometers per hour. At what angle relative to the longest side do you walk at? So lots going on in this question. Let's start off with a diagram with what's happening here. So we have this rectangular field like this, and we're told that you're standing on one corner of it. So let's say right here, and then you walk diagonally, right? And you could reach this corner in 10 minutes. And so you're walking on this path like that, and it takes you 10 minutes to go from this corner to this corner. So I'll just write 10 minutes right there for now. And then what else are we told? The shortest side of the field is 800 meters. Well, notice that this is the longer side, this is the shorter side. So this side here is 800 meters. And then you walk at a pace of 9 kilometers per hour. And so notice that we're given the speed at which you're walking at, and then we're given the time that you take to go from here to here. Well, notice with the speed and the time, we can actually find out what this distance is going to be. Okay, and then what they're asking is at what angle relative to the longest side do you walk at? Meaning that to the longest side, what angle to the longest side are you walking at? So they're asking for this angle right here. And notice that this is a right triangle that we have here. And so we'll be able to solve for this angle using the shortest side that we're given and then this diagonal side, which in the case of a right angle triangle, that's just going to be the hypotenuse. But what we have to do is we have to actually find the length of this side. And again, we could do that by using the speed at which you're walking and then the time at which you're walking. But notice that this is all in different units. Okay, so just in general, we have distance is equal to the speed times the time. Okay, but the speed is 9 kilometers per hour. But notice that the time is in minutes, and it's 10 minutes, like that. And so we can't multiply these smoothly here because this here is in kilometers per hour, which means that the time has to be in hours in order for us to get a distance, in order for us to multiply these, right? The time units have to be congruent. The hours, here we have minutes, so we're either going to have to convert this speed to be 9 kilometers per however many minutes, or we're going to have to convert this minutes into hours. I think I'm going to convert the minutes into hours. So 10 minutes we would multiply this by what? Well, there's 1 hour per 60 minutes, like that. So then the minutes cancel out, and so we'd end up with 10 over 60, which gives us 1/6 of an hour, right? 10 minutes is the same as 1/6 of an hour because there are 6 10-minute periods in an hour. 6 times 10 gives us 60. And so we can convert this minutes here to be 1/6 of an hour. Whenever you're given minutes and you want to convert it, and you want to convert that to however many hours, you just take those minutes, divide it by 60. This is just a proper way to show it here with how the minutes cancel out, and then you're left with the hours right there. Okay, and then so from here, we can now multiply these. 9 times 1/6 would give us 1.5, and the hours would cancel out, and we'd be left with 1.5 kilometers like that. However, there's another issue. This is in kilometers, so this side here, we got 1.5 kilometers, but what's the problem? Well, this side here is in meters. So again, we need these to be the same units in order to solve for that angle. So we can either convert this meters to be kilometers, or we can convert this kilometers to be in meters. I think I'm going to convert the kilometers to meters, so 1.5 kilometers, well, there are 1,000 meters per 1 kilometer, like that. The kilometers cancel out, so we end up with 1,500 meters, right? 1.5 kilometers is the same as 1,500 meters. You can also convert the meters to kilometers. 800 meters would be the same as 0.8 kilometers. Again, I just chose to go this route, but you can keep the 1.5 there and then use this side as 0.8. You'll still get the same angle when you solve for it. All right, and so now we could erase this, we have a triangle to solve. We have the angle to solve in the triangle. Now, with that angle, if we use that as the reference angle, notice that this is the hypotenuse, right? The side that is opposite to the 90 degrees. And then this is the opposite side to this angle. And then this here would be the adjacent side. We're not given that, so we're going to use these two sides. And what ratio uses the opposite and the hypotenuse? Well, the sine ratio. So we could say sine theta is equal to opposite over hypotenuse, so 800 over 1,500, like that. And we're solving for the angle, so what we do, we inverse this ratio, like that, in order to get that theta. And when you do that calculation, you'd end up with 32.2 degrees, right? So that there would be the answer. So that's the angle at which you're walking at relative to that longest side, like that. That is the final answer.